Now there are quite a few problems that will ask you to find the area of a shaded region. If this is the case, typically what you're going to have is two shapes. One shape is not shaded, one shape is shaded. So my suggestion is to first write out, well, what shapes are you given with in this problem? So you're given in this problem a rectangle and a triangle. You know you're going to have to find the area of each figure first. So let's do that. The rectangle has a length of 12 and it has a width of 4. So we're going to do 12 times 4 for my rectangle. So 12 times 4 is going to give you 48 centimeters squared. My triangle, remember, it's going to be base, which is 9. The height is the same as the width of the rectangle. So we're going to do 9 times 4. Triangles, you always want to divide by 2. So 9 times 4 is going to give you 36. 36 divided by 2 is going to give you 18. So what do you do with this? Now that I've found the area of the rectangle and now that I've found the area of the triangle, what do I do with these two answers? Keep in mind, it's almost like you're getting rid of the triangle. Imagine taking a pair of scissors and you're cutting out the triangle because you just want what's left over. In that case, what we're doing is we're taking the area of the triangle and subtracting it from the area of the rectangle. So if we do 48 minus 18, that's going to give us an area left over of 30 centimeters squared. Now, when you're dealing with a word problem, how do you know it's an area problem or how do you know that it's a perimeter problem? Area always deals with the inside of a shape. So if you're painting or covering something, that's going to be your area. Perimeter always deals with the outside edges. So a practical example would be putting around a fence around something, or if you're putting up a border or putting up molding in a room. So let's see what a practical example would look like. This one says Susan is helping her father measure the living room because they want to buy new carpet. The floor is in the shape of a rectangle with a width of 10 and then a length of 14. The carpet costs $1.75 per square foot. How much will it cost to buy the exact amount of carpet needed to carpet the living room? I will tell you, anytime I'm not given a picture dealing with geometry, I always like to draw one because I'm a very visual person. So this is 14 feet and this is 10 feet. Now, carpet means I'm dealing with area. I'm covering up the floor. So this is going to be area of length times width, so 14 times 10, which is 140. Now, this doesn't exactly answer my question, though, because it asked me how much is it going to cost. So it's 140 square feet times $1.75 per square foot. So if we multiply 140 times $1.75, it's going to cost me $245 to carpet that room. Now this same room needs baseboard installed around the base of the walls to hold the carpeting in place. Baseboard costs $2.35 per square foot. There's one 6-foot wide entry that does not need baseboard. Find the exact amount of baseboard needed and the exact cost. So again, think about what you are looking for here. Baseboard is around the outside edges, so we know we're looking for our perimeter here. We're going to add all 4 sides of that rectangle together, which is going to give me 48 feet. Now, one thing to note in this problem is there's a 6-foot wide entry that does not need baseboard. That means we need to take out 6 feet from our perimeter here. So this is going to be 42 feet. And then we're going to multiply that by $2.35 per square foot. So if we do 42 times $2.35, we get that baseboard is going to cost $98.70. Another concept that you're going to need to know for the geometry unit is going to be the Pythagorean theorem. It's probably one of the most famous formulas found in all of mathematics, which is a squared plus b squared equals c squared. The Pythagorean theorem is used to find the side lengths of a right triangle. Do not get this confused with the area formula. So area is used to find the area of a rectangle, which is the inside space here. Area is base times height divided by 2. This formula here is used to find the side length of a right triangle. So if I'm asked to find any side length of a right triangle, this is the formula that I'm going to use. One thing that's very important for you when using the Pythagorean theorem is to be able to identify the legs and the hypotenuse of a right triangle. The legs always form the 90-degree angle. I tell students it looks like a chair. So here's your chair right here. So imagine the little chair, somebody's sitting in it. If you're asked to find the legs are going to be the bottom of the chair and the height of the chair. So these two here, A and B, these are both legs. C is always the longest side, is always the slanted side. This is going to be your hypotenuse. This is, again, it's always the longest one. It's across from the chair. Steps to using the Pythagorean theorem. You always want to square whatever sides are given to you. Remember, square means to raise to the second power. Step 2 is you're going to decide if you're going to add. So if you're looking for the hypotenuse, then you're going to add your answers together. If you're looking for one of the legs, you're going to subtract your answers from each other. After you add or subtract, you always want to take the square root of your answer. Now, some of these square roots are not pretty, so you're going to need to use your calculator. If you got a TI-30 or a TI-34 calculator, you'll notice that there's an x squared key, and then right above it, written in purple, or it's like a bluish purple, is a square root symbol. Now, in order to get to that square root symbol, you have to first hit the second key, which is at the top left-hand corner of your calculator, and then you have to hit the x squared key in order to get your square root to come up. Once you do that, you'll be able to put the square root of whatever number that you're looking for. So let's look at some examples here. The first thing you need to establish is, what type of problem am I given? Here's that chair, right? That chair I was talking about. Do you know the two sides that touch the chair? Well, yes, you do. That means you are given both of the legs and you're looking for the hypotenuse. So we know we always start by taking our two numbers and we raise them to the second power. 13 times 13 is 169. 8 times 8 is 64. Now, if you know both the sides that form the chair, I know that's not a mathematical term, but you know what? It helps me. Both the chair sides, it means you add them together. So 169 plus 64 gives me 233. Do not put 233 as your answer. You always take the square root as your last step. So the square root of 233 gives me approximately, because I'm going to round it, is going to be 15.3 kilometers. In this problem, here's my chair, so always look for that right angle. Notice you know one side and you're missing the other. If you're missing one of the sides of the chair after you raise them to the second power, I know in this case I'm going to be subtracting. So I'm still going to take 11 and raise it to the second power. I'm still going to take 6 and raise it to the second power. So this is 121, and this is 6 times 6, which is 36. But notice I'm going to subtract this time. I'm not going to add them together. So when I subtract, I get 85. And then you always take the square root as your final step. So the square root of 85 is going to give me 9.2 if I round it. So approximately 9.2 centimeters. I want you to pause the video and try some Pythagorean theorem problems on your own, and when you're ready, hit play to check your answer. I know this is upside down, but again, here's my chair. My chair is just upside down here. I know both of the ones that touch that chair. So when I raise them to the second power, 7 times 7 is 49, 4 times 4 is 16. Notice I'm going to add 49 and 16 together, which is going to give me 65. I'm then going to take the square root of 65, which is going to give me approximately, if I round it, I'm going to round it to the tenths place, is going to be 8.1 centimeters. Again, to establish what you know. Here's my chair. I know one side of it, but I don't know the other. So if that's the case, I'm going to still take these numbers and raise them to the second power. So 2.8 times 2.8 is going to give me 7.84. If I do 1.9 times 1.9, that's going to give me 3.61. Instead of adding, I'm going to subtract because, again, I'm missing one of the legs here. So 7.84 minus 3.61 is going to be 4.23. It's very tempting to put that as your answer, but always remember your last step is going to be to take the square root. So the square root of 4.23 is going to be approximately 2.1 kilometers.